In a galaxy far, far away, two giant black holes appear to be circling each other like fighters in a galactic boxing ring. Gravity is causing this death spiral, which will result in a collision formation of a single black hole, a massive event that will send ripples through space and time. The collision itself happened eons ago. The two black holes are located about 9 billion light-years from Earth. Scientists won't be able to document it for 10,000 years. Even so, there are imperceptible gravitational waves generated before the collision that are hitting us right now. These waves from the black hole's activity will increase, but will not affect Earth. However, they could help increase our understanding of how our universe has evolved. When two black holes collide, it's one of the most violent events in the universe. These cosmic giants, which can be millions or even billions of times more massive than our Sun, have an intense gravitational pull that warps the fabric of space and time around them. When two of them come together, the resulting merger releases an incredible amount of energy in the form of gravitational waves, which ripple through the universe at the speed of light. The collision of two black holes begins when they're drawn towards each other by their immense gravitational pull. As they get closer, their strong gravitational forces cause them to spiral towards each other faster and faster, until they finally merge into a single black hole. During this process, the black holes release a tremendous amount of energy in the form of gravitational waves, which are ripples in the fabric of space-time. The amount of energy released during a black hole collision is staggering. In fact, it's so vast that it's hard to comprehend. When two black holes merge, they release more energy than all the stars in the observable universe combined. This energy is carried away by the gravitational waves that are produced during the collision. Gravitational waves were predicted by Albert Einstein in his theory of general relativity, but they were only detected for the first time in 2015 by the Laser Interferometer Gravitational Wave Observatory. Since then, LIGO and its European counterpart, Virgo, have detected dozens of gravitational wave events, including many black hole mergers. Studying black hole collisions is important for several reasons. For one, it helps us understand the nature of gravity and the behavior of extreme objects in the universe. It also gives us a new way to study black holes, which are notoriously difficult to observe because they don't emit any light. By detecting the gravitational waves produced during a black hole merger, scientists can learn about the masses, spins, and other properties of the black holes involved. Black hole collisions may have played a key role in shaping the universe as we know it today. The energy released during these events can have a profound effect on the surrounding environment, including triggering star formation and influencing the growth of galaxies. The collision of two black holes is a rare and spectacular event that releases an incredible amount of energy in the form of gravitational waves. By detecting these waves, scientists can learn about the properties of black holes and the nature of gravity itself. These events also play an important role in shaping the universe, making them a fascinating subject of study for astrophysicists around the world. If you enjoyed this video, then give it a like and make sure to subscribe and click that notification button. Thanks for watching.